welcome to the IMS Gate Academy. How are you all? So please confirm audio and video both. So everything is clear. Please confirm so that we are good to go with the video and the lecture as well. So please confirm whether both are clear or not. If it is not, then please write in the chat box. I hope that everything is clear here. Okay, so yeah, as you know that we had started the foundation series quite a week back, and we have completed a lot of lectures related to the respective subjects. And as you all know that I am discussing over here the electrical machine. In that the two lecture is already over. First introduction part we have did. Ajay, voice बहुत low है sir. अजय अभी भी voice low है क्या? Please confirm. Mathan, good evening. Please confirm Mathan and Ajay. अभी भी voice low है क्या? Audio clear sir. Okay, so अजय एक बार थोड़ा सा वॉल्यूम चेक कर लेना अपने लैपटॉप या फिर मोबाइल जो भी जिसमें भी आप देख रहे हो, कहीं आपके एंड से तो वो लो नहीं है ना. Okay, all right. So yeah, the two lectures were already happened, and in that we had seen the introduction of the electrical machine, and the second lecture was on the electrical material. Okay, audio clear sir. Thank you Mathan. So this is going to be the lecture number 3, in which we will going to discuss the magnetic material, as you have already seen in the thumbnail. Yes sir, मेरे मोबाइल में फुल है. ओके, तो एक बार चेक करो, यहाँ पे सब कुछ सही है. ऑडियो वीडियो से हमने क्रॉस चेक कर लिया है, तो यहाँ पे सब कुछ सही है अभी. एक बार आप अपने एंड से भी चेक कर लेना अजय. ठीक है. So we'll start with the next topic, that is magnetic material. And before that, if you are new to our YouTube channel, please do subscribe our YouTube channel. It is very important. And also do not forget to hit the bell icon button, because whenever we are coming up live in any kind of live event, so that you get instantly notified about that. So this session is definitely going to be helpful for everyone. So for that one help is required, and what is that? Please do hit the like button as well, and share the session link with your friend and colleagues, so that we are going to have the more number of students and the competitive environment as well. Okay, so before starting the lecture, let me take you to our online program and the features. Suppose if you are going to enroll for the or if you are going to give GATE 25 or 26 exam, then this is our online program where the features are 800 plus hours of the live class with live interaction, theory book, exercise book which contains 4000 plus question including all the subjects, 34 plus years GATE question bank with video solution. This is a USP of IMS GATE Academy. So we are providing you 34 plus years of GATE question along with their video solution. Next, 12 personalized one-to-one mentorship session, where the student and faculty will interact one-to-one personally, and whatever doubts that you are having, you can ask to faculty directly. So our esteemed faculty definitely going to help you out. And the last one is 130 plus online test with video solution of mock test and the many more. So if you want to wish to enroll in our online program, then you can book a free counseling by clicking on the link given in the description, or else you can call over this number. All right. So this is our Telegram channel, in which we are posting the schedule of free YouTube lectures, the lectures PDF. Once whatever session that is conducting over the YouTube, the PDF of the same is going to be shared over the Telegram channel. Important updates related to the seminar and webinar, PSUs and other government job notification, expert session on important topic, and daily quiz and many more. So Ajay, please confirm whether audio is now clear or not. So if you want to join our Telegram channel, the link is already given in the description, or else you can visit to this website. All right, so in the last lecture we had discussed about the electrical material, and in that I told you which material is used to make the power system conductor, and which material we will going to choose for the winding in the electrical machine. Ajay, please do confirm. Okay, so this is lecture number 3, magnetic material. All right, so here are some theory. So what about magnetic material? Any material which exhibit magnetic property is known as magnetic material. These properties arise from the alignment of the magnetic moment, that is spin of the electron within the material. There are three main types of magnetic material, and what are those? Diamagnetic material. This material exhibit a weak and negative magnetic response when subjected to an external magnetic field. So do not get worried, we will going to discuss all the material one by one. They have no permanent magnet movement and do not retain magnetization or magnetism once the external magnetic field is removed. Example are what? Copper, gold, silver. Paramagnetic. These material exhibit a weak magnetic properties and are only weakly attracted to an external magnetic field. They do not retain magnetism when the external magnetic field is removed. Example are aluminum, platinum and titanium. And the last one, which is very important, ferromagnetic material. These material have strong magnetic properties and exhibit permanent magnetization even in the absence of an external magnetic field. Example are iron, nickel and cobalt. So let us discuss the, what happened? Just a second. Okay. So let us discuss the diamagnetic material. So diamagnetic material are the substance that exhibit a weak repulsion or repulsion towards an applied magnetic field. When placed in a magnetic field, diamagnetic material generates a magnetic field in the opposite direction that we had already discussed. So you can go through this particular statement, and example we have already seen, copper, silver, bismuth, gold and many more. Okay. So why it is not working? Okay, all right. So see here everybody. So let me choose a material. Which is a diamagnetic. Okay. So let me take a material like this. This is the material that we have. Now what do you mean by sir, ferromagnetic material में कौन से टॉर्क अलाइन करते हैं मैग्नेटिक डाइपोल को? What do you mean by कौन से टॉर्क अलाइन करते हैं? What kind of torque you are talking about, Ajay? And also see, basically ferromagnetic material, what it is doing, it is transferring the energy from one side to another side. And ferromagnetic material, whatever the alignment it is going to be, definitely we will discuss, whatever alignment it is going to be have, it depends on the magnetic force applied. आपने H पढ़ा होगा ना, H magnetic field intensity. Please do not get confused with the magnetic flux density. Magnetic field intensity is H, magnetic flux density is B, and magnetic flux is phi. So whenever magnetic flux intensity is applied, then in the same direction your magnetic field is going to be aligned. That is the dipole. ठीक है अजय? Okay, so see, this is one material in which, in the absence of magnetic field intensity, that is H equal to 0. That is H equal to 0. Then there will be no dipoles present in the material. Am I clear? Am I clear? Now see what is going to be happen when you give the magnetic field intensity. When H is not equal to 0, and let me take this is applied in this direction. Whatever doubt you are having, Ajay, please do post in the chat box. I am really feeling quite good that you are posting the doubt on a regular manner. So please do not have the doubt in your mind, please post in the chat box. Even the doubt is the simple one. Definitely I will going to rectify all the doubts. So yeah, let us move ahead. So let me take the case where the material, the diamagnetic material is under the presence of magnetic field intensity, and this is applied in this direction. So see what is going to be happen. Dipole means what? Which is having the two pole. Dipole means two pole. So it will going to have the chota pole under like this, north, south, north, south, north, south. So these are the dipoles, north, south. Let me make it north, south, north, south, north, south. So the dipole will going to have the n number of dipoles depending on the material. Just for the sake of convenience, I have drawn here only 8 dipoles. So if you see very carefully, this north and south is going to be cancelled out. This north south is going to be cancelled out. North south is going to be cancelled out. So at the extreme left, what you are going to having? North. And at the extreme right, what you are going to have? South. So this material under the presence of magnetic field intensity, it will be like this. So I'm drawing this diagram particularly here. So you are having north like this and south like this. Done. And this is now going to be your magnetic material because you have applied the magnetic field intensity or magnetic force, you can say also. Am I clear? Done. So see the direction. Let me change the color. Okay, yeah. So see the direction of magnetic field, as we know that it will start from north. This is air, move out to air and goes like this, and from in the material it will enter from the south, and inside the material it moves from south to north like this. Outside it is north to south. Similarly, let me draw one more like this. Any doubt till this point? Okay, yes, we have a question. सर मैं प्रोसेस जानना चाहता हूँ. पहले H0 था, फिर H अप्लाई किया तो तुरंत टॉर्क बन गया कि दूसरे स्टेप में जो डोमेन के लिए डाइपोल को फील्ड के डायरेक्शन में रोटेट कराते. यहाँ पे टॉर्क का कोई कॉन्सेप्ट नहीं है अजय. यहाँ टॉर्क कहाँ मैंने यहाँ पे दिखाया आपको? देयर इज नो टॉर्क एज ऑफ नाउ. ठीक है, तो आप इलेक्ट्रिकल मशीन को अभी यहाँ पे लाके कंफ्यूज मत हो जाओ. दैट यू हैव स्टडीड द टॉर्क इन डीसी, इंडक्शन एंड सिंक्रोनस. It will going to be confused. We are starting from the basic level ना. So there is no concept of torque as of now. ठीक है, we are only talking about the magnetic field and magnetic force means this H. ठीक है, so please उससे confuse मत हो जाना torque से. अभी torque का कोई concept नहीं है यहाँ पे. Okay, all right. So this material under the presence of magnetic field intensity, which is in this direction, is going to be like this. Okay, समझ में आ गया? So see. Definitely I will going to discuss in a much easy manner, but for that I require you to be focus more on the lecture. Okay, definitely you should ask the question, but once I will going to complete this particular session, all the question will going to be whatever doubt you are having, those are going to be rectified. Okay, all right. So see what external field that we have applied, that is EXT. I will write here, which is not equal to 0. And what is the direction? Direction is from left to right. But if you see the direction of magnetic field intensity inside क्या हो रहा है? South से north जा रहा है ना? तो देखो, don't you feel it is opposite to the applied magnetic field? This is H internal. So which is in this direction. एनी डाउट? सो यहां पे जो आप देख रहे हो, सी द डाइपोल, यहां डाइपोल को लाइक हाउ द डाइपोल्स आर अलाइंड, दोस आर बेसिकली denoted in the form of magnetization. Means how the dipoles are going to be aligned with themselves are represented by the magnetization. So let me write the statement here. Magnetization. Okay, so which is denoted as, which is denoted as M. See the definition, the ability of dipoles to align when magnetic field intensity or force, you can say, H is applied. Am I clear? Any doubt in this? ये बहुत important line है, so please do that the definition is very important. Please do go through this definition very well. Okay. Now this M, I am not going to derive the magnetization formula. So let me write it directly. M, I hope you have studied this. M is nothing but equal to chi M into H. Chi M into H. So what is H? Here H is the applied external magnetic field, which is here. This H I have applied. And what is X? XM, it is, or yeah, it is XM, magnetic susceptibility. Okay. So what do you mean by magnetic susceptibility? Anyone? It tells you about how strongly your dipole is aligned when the magnetic field intensity is same. Am I clear? When the magnetic field intensity is same, then the magnetic susceptibility will tell you how strongly the dipoles are aligned under the presence of external magnetic field. Okay, all right. Done. So see here, Ajay and Mathan, see what is the direction of, kahan gaya? Yeah, see here, what is the direction of H external? It is in left to right. But what is the direction of H internal? It is from right to left. So don't you see that means, don't you feel that this both are different in the direction? So अगर इसको positive ले रहे हो तो definitely the magnetic field direction in this is going to be negative. What it means? It means that here since okay, because these two are going to have the direction, na? Since M is opposite to H, therefore M will be negative. Any doubt? Therefore M will be negative. कहने का मतलब क्या है? Here M, which is equal to chi M into H. So this is going to be negative only if X is going to be negative. Am I clear? ये negative कब होगा H से? When XM is less than 0. Then only it is going to be negative. But what is the effect here? What is the effect here? What is the effect of XM? For that, we need to understand the one more concept, that is relative permeability. How many of you know about the relative permeability? How many of you already heard the word relative permeability? Relative How many of you? The relative permeability is nothing but it is an ability of material to pass the magnetic field through them. समझ में आया मेरे कहने का मतलब क्या है? It is an ability of a material to pass the magnetic field through them. So that is nothing but relative permeability. Done. Now this is represented as mu. Let me change the color. This is represented as mu, which is nothing but mu naught and mu r. Mu naught and mu r. So this mu naught is okay. This mu r, relative permeability of a material. Done. And this mu naught is the relative permeability of everyone. Ajay, Mathan, this is what? Relative permeability of an air. Okay, of an air. And what is the formula? Oh, sorry, the practical value of mu naught. This mu naught is equal to 4 pi into 10 to the power minus 7. It is very important. So please do remember this value, because this you will going to use not only in the electrical machine, also in the power system, in the EMFT, and like whatever subject that is related to the magnetic. ठीक है? Done. So what is the relation here? Relation is mu r is equal to 1 plus chi m. This is chi m. So I am skipping the derivation part, which is not at all required here. Okay. Done. Now if you see, your chi m is negative. कहाँ गया? Yeah. Your chi m is negative. So can I say this is less than 1? Are yes or no? This is because this is negative. So 1 minus something will be definitely less than 1. So what it implies? It implies that your mu, कहाँ गया? Yeah. Your mu is less than mu naught. Are yes or no? Yes or no? Now one more term, that is magnetic field density. Magnetic field density, and it is represented by B. Okay, so what do you mean by magnetic field density? What do you mean by magnetic field density? It tells us about how closely your magnetic field are aligned in the material. Dense का मतलब क्या होता है in हिंदी? घना. So how densely your magnetic field is aligned in the material is nothing but magnetic field density. Any doubt in this? Clear है? So as you know that B, which is equal to mu into H, this we had studied in the EMFT. Okay, Ajay, are you there? So please do respond. Is everything clear as of now? Now what about magnetic field of air? Can I say it is mu naught H? And what about magnetic field of the diamagnetic material? This is mu into H. So diamagnetic up, what is permeability? This is the total permeability of the diamagnetic material. Done. Now I can say that since your mu is less than mu naught, which is here, mu is less than mu naught, so this implies magnetic field of dia is less than magnetic field of air. Is it clear, everyone? So see, what we can conclude from this statement or from this relation, not this statement, from this relation. Suppose this is a material that we have, and outside is a air, and this is ferromagnetic material. This is ferromagnetic material. It is better to draw like this. Just a second. Okay, so look at here. Suppose your magnetic field outside the material is like this. Then magnetic field will be apart in the material because the density is less, or the density of the magnetic field in the diamagnetic material is less when it is compared with the air. So air may, if it is like this, okay, just a second. Then in material, sorry, just a second. Okay. Done. Now if you see carefully, outside means at the air side, the magnetic field are very close, isn't it? And in inside the material, the magnetic field density are apart. देखो gap, यहाँ पर भी gap. Why it has come? Because of this particular thing. Am I clear? Any doubt in this, Ajay and everyone? So this is magnetic field density air, and this is a diamagnetic material. Magnetic material. So here B, like this thing is what? B of diamagnetic. And what is the direction? Flow of direction? Okay, what is direction of flow? It will be like this. Done? Okay, so we can say that when you going to choose this kind of material, okay, the diamagnetic material, which is copper, and that is what we discussed, then your magnetic field inside the material is going to be separated, which is not at all acceptable while designing the material for the electrical machine. Because what we want the flow of magnetic flux to be as minimum as possible. But if the magnetic field is apart, therefore opposition offered for the magnetic flux will be higher, and therefore it will be difficult to transfer the energy from one side to another side. Okay? So therefore we cannot choose this material, diamagnetic material, as a core of the electrical machine. Okay? Now let us come to the paramagnetic material. The paramagnetic material are those, any doubt in the last topic that we discussed? Please do post. The paramagnetic material are those that have a weak attraction to magnetic field. This is due to the presence of unpaired electron in their atomic or molecular orbital. Very important line. When these material are placed in a magnetic field, the electrons align themselves with the field, creating a net magnetic movement in the direction of the field. This causes the material to be weakly attracted to the magnet. Some common examples are aluminum, platinum, titanium. These materials are often used in the production of magnet as well as in the various electronic and industrial application where magnetic properties are important. Okay, so these are the things that we had discussed. But which material are suitable for the paramagnetic material? Those who are going to belong to the P block. आपने पढ़ा था ना इलेक्ट्रॉनिक कॉन्फ़िगरेशन और इलेक्ट्रॉन कॉन्फ़िगरेशन like 1s2, 2s2, 2p6 and something like that. We had discussed in the chemistry, isn't it? So the material which belongs to, as of now, the material belongs to D block is basically your paramagnetic material. So let me take an example of a material which is having the electronic configuration as 3, like third ring and of the P block, which is having the 4 outer electrons. So let me take 3p4. Okay, so 1, 2 and 3. Okay, just a second. Okay, so we need to accommodate this 4 electron in this cell. So how? 1, 2, 3 and 4. Done. Now this is what basically your paired electron. This the first part is your paired electron. If you see, you are going to have 2 pairs. Sorry, 1 pair. One is in upward direction and another is in downward direction. So basically this is said to be your paired paired electron. And if you see in the second and third part, you are not having the pairing of electrons. So this is said to be unpaired electron. And what is the function of unpaired electron? It will going to create the magnetic dipole. Because of this, the dipole are okay. So dipoles. So because of this, the dipoles are inside the material. And why? Because this is spinning of electron is not cancelled out. Okay, in the first part your spinning is cancelled out, so because of that dipoles are not going to be happen. Like you can treat north and south just in a layman term. So it is going to be cancelled out, but because of this two which is not cancelling out, the dipole is going to be created. ठीक है? So in a simple manner this is going to be represented like this. ये dipole को कैसे represent करेंगे? It is lying in south to north like this. See, okay, sorry, south to north. So instead of this, I will going to use this one. Okay, so this is the representation of the equivalent of the particular dipole. Now suppose if you are having the material like this, just a second. Suppose you are having the material like this. So as I told you, it will going to have the dipoles inside it because of this unpaired electron. So let me take the dipoles in this direction. Suppose ये कुछ इस तरीके से हैं, south to north, south to north, south to north, south to north. For the sake of convenience, I have drawn here only 4 dipoles. There will be n number of dipoles. ठीक है? तो इसको how we will going to represent the equivalent of this? Sorry, the equivalent of this. Just a second. can be shown with this movement like this. See here, south to north, na? So it will be like this in a simple manner. South to north like this, south to north like this, south to north like this. So this is when magnetic field is not applied, means magnetic field intensity is not applied. Any doubt? Any doubt, Ajay, Matan? Now what if magnetic field is applied? Means when H is not equal to 0. And let me take this, this is the external magnetic field which is applied in this direction. Ajay, any doubt? Okay, so when magnetic field is applied, see what is going to be happen. It will going to align in this direction, south to north, sorry. One dipole, two dipole, third dipole and fourth dipole. So your this part is basically south, which is what I have written over here, and this is north. This is south and this is north. South, north, south, north. So as we had discussed that this is going to be cancelled out. So in the extreme left, south will come, extreme right, north will come. So this can be drawn again like this. थोड़ा small बना रहा हूँ diagram because I want some space over here. Okay, so you will have north here and sorry, not north, south here and north here. And what is the direction of flow of magnetic field in this? Everybody? What is the direction of the flow of the magnetic field? It will be like this. Let me change the color. Outside is a air, na? Outside is a air. So, what is the direction, everyone? In the material, what is the direction? It is from left to right. And in air, it is right to left. Like this. Okay? So, this is nothing but your H internal. Done? Any doubt in this? So, let me change the color. So, can I say your M, which is equal to chi M into H? In this case, M and H both are parallel, means both aligned in the same direction. How, sir? We have applied H in this direction and we are getting the magnetic field in the of the material in the same direction. So therefore it is in the parallel. So can I say that is M parallel to H? So what it implies from this equation, what we can say that? We can say that your chi M is greater than 0. Your chi M is greater than 0. So your mu R, which is which is equal to 1 plus chi M, it is going to be greater than 1. So my dear friend, mu of a material which is equal to mu naught into mu R. So this is going to be greater than mu naught. So we can conclude that magnetic field density of of a material which is of paramagnetic, magnetic field density of a paramagnetic material, it is going to be greater than magnetic field density of an air. Any doubt in this? कोई डाउट है क्या? जल्दी से बताओ. So when you going to draw the material, or if you're going to choose a material like this of a paramagnetic, see what is going to be happen. Outside the air, it will be like this. Sorry, outside the material, not the air. This is the direction. It will be like this, and inside the material it will going to be closed, because magnetic field density in this is a ferromagnetic material. It is going to be densed more than the air, so it will going to be like this. Okay, so look at here. Done. So this is magnetic field density at the air, and this all thing are magnetic field density of a paramagnetic material. I hope this color are visible to you, and this particular thing is what? Paramagnetic material. Paramagnetic material. Am I clear, everyone? Now let us discuss about the ferromagnetic material. Okay. So the ferromagnetic material are those that have a strong attraction to the magnetic field and can become permanently magnetized. This is due to the presence of unpaired electron in their atomic or molecular orbital. That is what we had discussed in the paramagnetic as well. And the way their electron aligns themselves in the group called domains. When these materials are placed in a magnetic field, the domains align themselves with the field, creating a net magnetic moment in the direction of field. This causes the material to be strongly attracted to the magnet and can retain its magnetic property even after the magnetic field is removed. So it is very important line. Okay, from here. Okay, some common example are iron, cobalt, nickel and their alloy. So out of this we are using the iron for the core of the transformer, or you can say for the electrical machine. So ferromagnetism is different from both diamagnetism and paramagnetism. While diamagnetic material are weakly repelled by the magnetic field and paramagnetic material are weakly attracted to the magnetic field, ferromagnetic material have a strong attraction and can become permanently magnetized. How? I will let you know. ठीक है? Just a second. Okay, so see, the ferromagnetic material is basically are considered those material which belongs to D and F block. Like in the the paramagnetic material belongs to P block. Please do not confuse with the paramagnetic P, then P block, then diamagnetic means D block. No, it is not like that. The material which belongs to P block are considered as a paramagnetic material, and the material which belongs to D and F block are considered as a ferromagnetic material. So आज ही जाएंगे केमिस्ट्री में वो क्या वो टेबल बोलते हैं ना हम लोग, समथिंग मुझे याद नहीं आ रहा है. सो कोई मुझे रिमाइंड करा सकता है क्या दैट ब्लॉक को क्या कहते हैं? I forget that word. Okay, see, no issue. It is nothing to do with this thing. So yeah, the material which belongs to D and F block are considered as a ferromagnetic material. So let me take a material like this. Sorry. So this is your ferromagnetic material, which is again going under the absence of magnetic field. It will going to have the dipole in this direction like this. Okay. So when H is not applied, means H is 0. Let me take H like this. Okay. Now under the presence of, when H is applied, means when magnetic field intensity is applied, then what is going to happen to the dipoles? So look at here. Okay, so this is the second part na. So do not get confused with यार ये किसके लिए था, H equal to 0 या H not equal to 0. So this portion I am drawing for H not equal to 0. So see, the direction here we have applied in this. Then if you going to carry forward the concept that we had discussed in the paramagnetic material, then we can say that your dipoles are going to align in the same direction like this. When H is in this direction, when H is in this direction. Now some of you are thinking that, sir, then what is the difference between the ferromagnetic and the paramagnetic, because these two seems to be same? There is a huge difference. And what is that? Number of unpaired electrons. As I discussed in the paramagnetic, the unpaired electrons is going to give you the dipoles. So for the D block, for the P block, which is of the paramagnetic material, so the P block will going to have the less number of unpaired electrons, whereas ferromagnetic material which belongs to D and F block will have more number of unpaired electrons. So can I say it will going to have more dipoles? इसलिए मैंने यहाँ पे 6 बनाया है और यहाँ पे आप देखोगे मैंने 4 लिया था कुछ like that. ठीक है? So we can conclude from this that the direction of magnetic field for this will be south. Remember, इसको south से denote करते थे and इसको north से, isn't it? So this becomes south and this becomes north, and internally these two are cancelled out. North south will be cancelled out. So what is the direction here? Direction of flow of magnetic field? It will be like this. Sorry. It will be like this. So this is magnetic field at air, the direction, and inside the material it is magnetic field which is H internal, you can see H internal inside the material. So this is H internal inside the material. Or basically, it is better to write not this because it is incorrect. This is H internal. H internal. ठीक है, any doubt? Okay, now come to that property M, which is equal to chi m into H. And what is the direction of H external and H internal? Both are same na? External ka and internal ka, what is the direction? Same. So therefore, chi m is greater than 0. Chi m is greater than 0. As you know, chi m is equal to 1 plus, sorry, mu r is equal to 1 plus chi m, and it is much greater than 1. It is much greater than 1. Therefore, mu r is much greater than mu naught, or magnetic field density inside the material, which is much higher than the magnetic field outside the material or at the air. कोई डाउट यहाँ पे? ठीक है, सॉरी सर नेटवर्क नहीं था, कोई बात नहीं. ये वीडियो जैसे, ये सेशन जैसे ही एंड होगा, प्लीज गो एंड वॉच द लेक्चर वंस अगेन. डेफिनेटली एवरीथिंग इज गोइंग टू बी स्ट्राइक, एंड एल्स if you're having any doubt, you can comment in the chat box, sorry, in the comment box as well once the session is going to be over. Okay, so Ajay, have you joined our Telegram channel or not? अजय सर, स्लाइटली ग्रेटर देन का सिंबल क्या होता है? अरे नहीं, स्लाइटली ग्रेटर देन का सिंबल कुछ नहीं, वो सिंपली ग्रेटर देन से ही डिनोट करते हैं. इफ इट इज ग्रेटर, if it is higher, then we'll use 2 to 3 greater than symbol. Okay, so slightly greater और ऐसा कुछ किसी के लिए सिंबल नहीं होता है. If it is much higher or if it is higher, so for if it is higher, we'll use only one this symbol, only one this symbol, and if it is higher, we are using 2 to 3 symbol like this. Slightly higher के लिए हम लोग नियरली इक्वल टू ऐसा करके लिख देते, बट इट इज नॉट करेक्ट टू से हियर राइट नाउ. ठीक है सर, आपका नेम आ नहीं रहा है. मेरा नेम कहाँ नहीं आ रहा है? अरे नहीं, ग्रुप में द IMS गेट अकेडमी टेलीग्राम चैनल यू विल फाइंड इन द डिस्क्रिप्शन बॉक्स, दैट यू लिंक टू बी ज्वाइंड. अजय, ठीक है, ओके. जैसे मेरा नाम निखिल गौरव आप जान रहे हो, so if you want to personally message me related to the doubts, so you can message me, because in the Telegram group which you are supposed to be joined of the IMS, you will not able to share anything in that, क्योंकि हम because those are only meant to help out the student. फिर वही कि randomly हो जाएगा चीज़ें, अगर हमने बच्चों को अलाउ कर दिया तो बहुत सारी डाउट्स जो है उसी में पूछने लग जाएंगे. ओके अजय, so the link which is mentioned in the given in the description box, please do join that. Okay, कभी कभी परमेबिलिटी डायमैग्नेटिक मटेरियल में बोलते हैं कि परमेबिलिटी स्लाइटली लेस देन 1 होगा. हाँ, मैं अभी बता रहा हूँ, डायमैग्नेटिक मटेरियल में नहीं होगा, वो पैरामैग्नेटिक का होगा अजय. ठीक है, सो लुक एट हियर. सी, suppose this is a diamagnetic material. Assume that this is a diamagnetic material. Then, as I told you, outside the material, you are going to have the magnetic field like this. Done. But inside it is going to be dense like this. like this. ठीक है, like this. So this is magnetic field density at the air, and this is ferromagnetic material. Ferromagnetic material, and if you see, the magnetic field lines are closely packed with each other. So therefore, B of ferro. B of ferro. Any doubt? So see, if you see this diagram, and of the para one, which is here, it seems to be same. But it is not. Why, sir? The reason is, कहाँ गया? Yeah, the reason is this value chi m in the paramagnetic material, it is very, very less. It is very, very less, and it is nearly equal to, sorry, just a second. Okay, yeah, sorry, this value कहाँ गया? हाँ, yeah, this value chi m, this is nearly equal to 0.0015, like this. So this makes the mu r greater than 1, but if you see, this is nearly equal to 1. So this is the reason why I have not shown the lines to be a densely packed or closely packed. ठीक है? Whereas कहाँ गया? Yeah, see, whereas the mu r of a material, of the ferromagnetic material, it is this is nearly equal to more than thousands. Sorry. ठीक है अजय, कोई डाउट यहां पे? सो ये ग्रेटर देन 1000 क्यों हुआ? बिकॉज ऑफ दिस chi m, because chi m is greater than 1000, and this is going to be greater only if when you are going to have more number of unpaired electrons in the given materials. ठीक है? Any doubt? Clear? Now we are having one advantage of the ferromagnetic material. So look at here. When magnetic field intensity becomes 0, ideally what has to be happen to the dipole? It has to be non-aligned with each other. देखो ये क्या हो गया? Alignment. These are aligned. This is non-aligned. So when H is 0, then ideally dipoles has to be non-aligned with respect to each other. But what is going to be happen? Even if H is 0, the dipoles, just a second, the dipoles remained aligned inside a material, giving rise to residual flux density. ठीक है, एक मैं एग्जाम्पल ले रहा हूं यहां पे, ठीक है. सी टेक वन आयरन पीस, ऑलराइट, and apply a magnetic field intensity. Let me take one general example. Apply a or connect a voltage source in that material. Okay, so after some time remove the source and bring one non-magnetized material at the vicinity or near to the same material which was earlier connected with the source. So what you will see that the non-magnetized material is going to be attracted towards the given material or the old material. ऐसा क्यों हुआ? Because even if there is no source, the magnetic material will is possessing some flux inside that. So because of that flux, the non-magnetic material, basically not a non-magnetic material, the material which is new is attracted towards the old material. Okay, अजय सर, डीसी मशीन में आर्मेचर में फ्लक्स सर्कल शेप में बनाते हैं, ऐसा क्यों? एक बुक में दिया था, ऐसा क्यों बनाते हैं? आर्मेचर में फ्लक्स को सर्कल से बनाते हैं? नहीं, ऐसा तो नहीं है. आर्मेचर को सर्कल में बनाते हैं, नॉट द फ्लक्स. ठीक है, एक बार चेक कर लेना. वो तुम आर्मेचर की बात तो नहीं कर रहे हो? ठीक है, बट एनीवे इन जनरल द मैग्नेटिक फ्लक्स डेंसिटी ऑलवेज फ्लो इन अ क्लोज्ड पाथ, बिकॉज if the magnetic field is started then it has to be end at the same place. ठीक है, इसलिए बोलते हैं ना divergence of magnetic field is what? 0. Del dot B is what? It is always 0, क्योंकि magnetic field कभी भी diverge नहीं होता है, कभी भी diverge नहीं होता है. Okay, so yeah, so what I mean to say, this implies B is equal to BR even if H is equal to 0, So you might have seen this curve. Let me draw it. Okay, so if you have made a magnetic material, if you have made a magnetic material, then okay, let me mark this axis H and this is B. So for the first time when H is 0, then B is also going to be 0, and it will follow this path like this. Now when you reduce the H, it will going to follow this path. And when you increase the H in reverse direction, it will follow this path. Okay, so for the very first time, so this is said to be virginal curve. Okay, here even if you increase the magnetic field intensity, your magnetic flux is what? Constant. Therefore, this particular section is said to be saturation. Now, if you reduce the magnetic field intensity, then at H equal to 0, you are going to have magnetic flux density, which is BR, जो मैंने यहाँ लिखा था. दिखा? Done? Now, if you want to make this BR to be 0, if you want to make this BR to be 0, then extra force is required in opposite direction, है ना? Extra force is required in opposite direction. Therefore, this force is minus HC, which is known as coercive force, Now, increase the H in opposite direction, your magnetic field will going to be increase in reverse direction. ठीक है? Like this. And after some time, it again becomes saturation or saturated. Now, increase the magnetic field intensity in the positive direction, and at some point where H is 0, it will going to have minus BR. ठीक है, ऐसा मत समझ लेना plus 4 Tesla means for BR, then for minus BR it will be minus 4 Tesla. No, this minus sign represent the direction of magnetic field. Done. Now, if you want to make this minus BR or this residual flux to be 0, then extra force is to be required to make this BR to be 0 in opposite direction. तो ये negative है, तो H positive लेना पड़ेगा, means here. So, if you applied plus HC force, then you will going to reduce this minus BR. So, what do you mean by this? What do you, basically what this curve is known as? This is known as BH curve or hysteresis curve. क्या बोलते हैं इसको? BH curve or hysteresis curve. So, from here you can see that the direction will be, let me change the color, direction will be like this. So, 0, it will start from here, then 1, then reduce the magnetic field intensity, it will reach here, then 3, then 4. After this, it will increase H, then this point is 4th one, then 5th one, and again back to 1. So, if you see, for the first time, it will, for the very first time when the material is under operation, then it will follow this path, and once it will going to reach saturation and retracing it like this, like this, it will not going to follow the first segment, that is from 0 to 1. This is only happen for the first time when the material is in operation. ठीक है? So, this is what residual magnetic flux density. That is why the iron is will have some property even if H becomes 0. आपने कभी आपने देखा है ना कि मैग्नेट को मतलब if you are taking the iron near to the magnetic field, or let me take in general magnet, if you are taking the iron near to the magnet, your iron is going to be attracted. वो कब होगा? When you are having some magnetic flux density. ठीक है? So, this is nothing but your hysteresis curve or hysteresis loop. Okay. So, with this we have completed, any doubt, Ajay, Mathan? So, with this we have completed all the important things related to the magnetic material, and we come to know that the ferromagnetic material is the best choice for the magnetic material, because we are having the more number of unpaired electrons, therefore we are having the more number of dipoles, and and therefore the magnetic flux density inside the material is much higher when it is compared with the other material or air. Done. So, with this we have completed the lecture number 3. So, let me discuss about the Telegram channel. Ajay, if you are there, please go through the link which is given in the description box. So, these are the programs that we are giving in a free of cost in our Telegram channel. And what are those? Schedule of free YT lectures PDF. So, this PDF, this lectures PDF is going to be shared in this Telegram channel, which is mentioned over here. Then important updates, PSU and other government job notification, expert session and daily quiz. And if you want to enroll for GATE 25 and GATE 26 with us, then this is our online program where the program features are 800 plus hours of live classes with live interaction, theory book, exercise books with 4000 plus question, 34 plus years GATE question bank with video solution, 12 personalized mentorship one-to-one session, plus 130 plus online test with video solution of mock test and many more. So basically these two are the, these three are the USP of the IMS GATE Academy. This thing you will never going to get in the in this GATE domain. Okay, that is what we are offering to the student. So with this thing you will going to crack a good rank in the GATE exam. It is my word. All right. So if you want to do the counseling, then you can book a free counseling with us by clicking the link which is given in the description, or else you can call over this number. All right. So let me end the session. I hope you have enjoyed the session. So guys, please do press the like button because it keeps me motivated, and also please share the session link with your friend. And if you have not subscribed to our YouTube channel, please do subscribe and also press the bell icon, because whenever we are coming up live, you should instantly going to be notified about those sessions. Okay. So bye bye and take a very good care of your health.